A warm welcome to my garage workshop. I have this Bridgeport style milling machine with Anilam Wizard 150 plus digital readouts. However, now the DRO broke down. 2/3 of the axis went completely brain dead. It wasn't much fun trying to cope with only one functioning channel for a couple of weeks and wait this thing to arrive. It's a Ditron LCD display unit from eBay. Nowadays the scales are often plugged with these D79 connectors. The old unit was hooked with this kind of round military style connectors. My old scales are perfectly fine and with 5 micron resolution most suitable for this machine, and by no means outdated. The quadrature signals and 5V TTL levels are the same what the newer scales uses. There are cable adapters for this, but I didn't want to spend extra €100 pounds and bring additional weakest links to this shaky and dirty environment. Luckily I had one functioning channel, so it was quite easy to figure out the pin orders. And here's the table for you. I'm not going to show me soldering these wires with my shaky hands, but here's how it turned out. The blue wire in the Anilam cable has no function. Simply cut away. For a medium-sized surprise, all the readings functioned at the first try. Then I made a bracket for the new RPM sensor, which came with the package. 2 magnets were superglued to the brake drum in the top of the spindle. Another bracket was made for milling machine control switch box. Here's how things look from the rear end of the display. The main reason for buying a 4-channel display is the Quill scale. I've had this digital scaling in the Quill for a while now. It kinda does what it should, but usually with a blink for a low battery. There's no auto power off feature. The refresh rate for the display is terribly slow, and therefore I usually end up drilling far too deep holes. There's a data output port in the scale, but there's no easy way to convert the signal for the DRO. There isn't much room for a full-size glass scale, because I want it to remain the good access to the milling head tilt bolts, and occasionally swing around with my toy hammer. So I bought this MDRO 5 micron pickup and a strip of magnetic tape. The system was plug and play connected to the DRO. The magnetic tape needed some backbone, so I took this stainless steel bar and milled it to the same size the older Quill scale had, so I could use the old brackets. Someday I will gain money, power and women from making these videos, and I can buy another modular milling vise. But meanwhile I must cope up with this lopsided setup. Here I'm milling a groove for the magnetic tape. And some Scotch-Brite touch-up. Laying magnetic tape on its groove. And a shielding strip of thin stainless steel on top. Milling a slide bearing out of Delrin. And an aluminium bracket. I added a strip of PET plastic to swipe ferrous debris before the pickup. The result doesn't underline the fact that it was made in a shed located 60 kilometers west from middle of nowhere. In the display settings, I can configure the U-axis being a combination of the Quill and the Z-axis. Here is how the axis summing feature works. I reset the imaginary tool to the workpiece top, and then I change the table height, and the combined scale still knows my actual tool height. But there's a major drawback in the combined scale setup. The DRO just sums the display values, not the actual signals. It leads to very annoying situations when the Z-axis or the combined U-axis is reset. It is most urgent that both axes are reset or you are screwed with your tool heights. And that's why I placed an order for an encoder signal summing interface. Another reason why I ended up hating the fourth axis in the display is the alignment between the axis value and the reset buttons. The Z-axis and the U-axis buttons are awkwardly off the line your finger would naturally gravitate to. The problem is even more pronounced when the spindle speed is displayed. It would be nice to have the RPM value displayed in the background, just like the feed rate is. I made a 3D printed sign to guide my finger to the correct row, but that wasn't much help. I probably stick to 3-axis setup, at least when the Quill summing device arrives. And now we can jump to the cool gadget of the new display. Most useful for me will be the circular hole pattern. Hole pattern functions have been around for a good while in these things, but the LCD display is certainly bringing this to a more user-friendly form. The user logic is just what you can expect for the price, and can sometimes be frustrating when an enter key hit has forgotten. But here is when the LCD really kicks in. I want to change the pattern start angle, and I get graphical feedback instantly to check that the things went in the way I wanted. The next task is to sync the orange chip with the red cannonball. Drill the first hole and move to the next. Another neat thing where the hole pattern function can be used is for widening a hole. Here I want to make 36 mm hole with a 25 mm end mill. The difference in the diameters is 11 mm, and here I'm giving a half a millimeter for the finishing cut, and making the roughing cut in 12 divisions. The DRO thinks we are drilling holes, but I'm just widening the bore. Here's the result from the roughing cut. A good start for a boring head operation. But in this case I wanted to bring things one bit further. I will make the final cut by interpolating the circle with the hole pattern function. I'm making the final cut slightly loose fit and use 48 divisions for the cut. This is real human-aided manufacturing. Moving clockwise here gives less chattering in the cut and better surface quality. The fit is quite nice here. I think this method can be used for something more accurate boring too. The closer the mill diameter is to the desired bore, the better the result will be. And here is what that flange was meant for. I have this rotary encoder with 5000 pulses per revolution accuracy. The Quadrita signal system is kind enough to multiply the resolution by 4, so I have 20,000 positions per one revolution here. The encoder snaps with magnets to my dividing head. The angular position of the dividing head can now be read from the DRO. My U-axis is now configured as rotary. Here I'm making a timing belt pulley with 40 teeth. That means 9 degrees of turning between the cuts. In order to calculate the 9-degree turns with my fingers, I had to do some fine-tuning to my limb setup. Hopefully I come with a better solution for this, because my next project requires 7.5-degree turns. My quick and dirty encoder mount has few major design flaws. The encoder obviously stocks the dividing head bore for longer stocks, and the encoder hits the stopper block when 30-degree tilt is exceeded. So I decided to move the encoder from the center to this side. I CNC milled a frame and a housing from 6mm aluminium plate and bought some timing belt stuff. Then I removed the hub nut for some modification. I turned a recess behind the threading. Then I removed the flanges from the bigger timing belt pulley. Made the bore bigger and turned a matching diameter for the hub nut. Drilled few holes. And reassembled it back to the dividing head. One of the screws jams the nut just as it was in the original design. Then I placed the belt and adjusted the tension. You may have noticed that I have a step-up ratio here. As the dividing head turns one full turn, the encoder takes 3.6 revolutions. This is for matching the output resolution to my linear scale. We'll get back to this later, but let's first finish the assembly. I uploaded the CAD model for this to the GrabCAD service. There's a link in the description. Now the system has an open bore and just clears the obstacles in the vertical position. The dividing head can now be plugged to any channel in the display without any changes to the signal settings. 1 mm equals 1 degree. Why is my rotational axis now hooked to the Y channel and the Y-axis scale is temporarily moved to the U channel? Here's the reason. Linear pattern function can't be used with the U channel. I choose the XY plane and length for the string 360. I want 12 divisions, but I must input 13 here because 0 and 360 is the same position. Then I orientate the string to Y direction. Let me clarify what's going on here. I want to do some machining to a solid of a revolution. I let the DRO think that I'm drilling holes in a row. The workpiece here is 360 long and 30 between the 12 holes. DRO is talking millimeters, and I'm doing degrees. I feel a little bad cheating like this in this early stage of our relationship. Now we are finally sucking diesel here. I can easily make this part with my new digital friend. I just don't know yet what this part is meant for. I think these indexing plates are never going to sit on my dividing head again. I hope you got something out of this video. I had a lot of fun playing around with this new display, and despite the few of its flaws, I have learned to like it, and not at all sad that the old unit bited the dust. And since you're still watching, you may also like my next project. Stay tuned for my CNC lathe build video.